Hi everybody, welcome back to the Feynman technique. Um, I know I haven't posted anything and I think it's been almost a month. I've been very busy with my AP Calculus tutoring, so I haven't had a whole lot of time to dedicate to the channel. I don't make any money off of this channel. This is just kind of like a passion project of mine. But anyway, what I want to do today is get your opinion on a new video style. So this is going to be it. And this is just going to be a preview video of what the style is going to look like. Um, Leave your thoughts in the comments. If I don't hear anything, I'm going to assume it's good. Anyway, so in the first video in this preview, we're going to be just going over the Leibniz rule, or the Leibniz rule for differentiation under the integral sign one more time using this new video format. All right, so in plain English, we start by defining a function of t. It's defined by an integral where the variable t is inside the integral, acting like a parameter we can tweak. See, normally we would only have a function of x dx, but this is a function of x and t. And this will become a function of t once you plug in the bounds of integration into your variable x. So our goal is to find the derivative of that function of t directly. Okay, so this is our goal. We want to find the derivative with respect to t of our original f of t. Okay, so let's break out the limit definition of a derivative. You guys all know what that is, but basically all we do is we have this is our original f of x and t, and this is the limit definition of a derivative. We just plug this into that limit definition and we get this. Okay? We literally just plug this is our f of t right here. So we plug it into our limit definition of a derivative. So since both integrals have the same limits, we can combine them into one integral. So let's go back to the previous step. This is what we had before. So you'll notice they have the same bounds of integration, so we can combine the integrands into one integrand. And also you'll notice that we brought that 1 over h inside the integral because it's constant with respect to x. So now we have this. Next is the most critical part, and unfortunately, it requires some concepts from analysis that we're not going to get into. It makes intuitive sense that you would be able to switch that limit, since an integral is just a bunch of things added up together, and you know that you can take the limit of a bunch of things added together is the same as adding them together and then taking the limit. Now, there are some exceptions, and like I said, without getting into analysis, we can't really prove that you can put that limit inside, but you can. It's been proven you can do that, so we're going to do that. We bring the limit inside. And now you'll notice that what we just created right here, this is exactly the limit definition of a partial derivative of a function of x and t with respect to t. So that is exactly what that becomes. So finally, we have the Leibniz rule for differentiation under the integral sign. And basically what that says is that if you have an integral from a to b of a function defined in terms of x and t, or any other two variables integrated with respect to one of the variables, you can take the partial with respect to the other variable. You can take the entire derivative of that function with respect to the other variable simply by bringing the derivative inside the integral as a partial with respect to t. All right, guys, so let me know your thoughts on the new format. I think it's much easier to read. Um, it's just clearer. So again, give me your thoughts in the comments. Let me know, and we'll see you next time.